This is Geometry 4.1. We're going to talk about the triangle sum theorem. The angles inside a triangle are called interior angles. Interior. When the sides of a polygon are extended, I'll draw a triangle because that's just nice and basic. So there's my triangle. When the sides are extended, when we extend the side, we're talking about pushing that side still farther out. And we create this angle on the outside of the shape. And we can extend the other side of the triangle. And we create another angle. And just like that, we can do the third side. So the angle that is formed on the outside is called an exterior angle. These angles form linear pairs with the interior angle. A linear pair with the interior. And are called exterior angles. Now, if you would extend the green over the blue and extend that one out, you would have another set of exterior angles. But typically, we talk about having just one pair of exterior angles per vertex. And we'll learn special properties about those. All right. Here's an activity that we can take a look at. You are welcome to cut a triangle. Any type of triangle you wanted to cut, doesn't matter what type you cut. So I chop that one down. You could cut your own triangles at some point if you like. I'm going to trace the sides here so we see exactly where the angle would be. We'll call that angle 1. I'll trace these sides so we can see where the angle is. Call that angle 2. We'll trace these sides so we can see the point where the angle is. So you don't want to get confused, because now we're going to take our triangle, and everyone might have a different size triangle. I got one angle, I have another angle, and I have a third angle. I ripped my angles right off of my triangle. And what we can try to do, I'll put them up here so it might be a little easier to see the difference on the contrast. You go in any order you want, doesn't matter. But the reason I traced out these angles is so that we knew exactly which one of these corners was the vertex, right? So this was pointing to that vertex, this one was pointing to that vertex, and this guy was pointing to that one. What do you notice about all three angles? That's an example. This is a different example. Angles are a little bit different here, of course, which is just fine. It's just a different triangle. What did you notice about both sets of angles? Both sets of the three angles of a triangle. They always do what? They add up to a straight line, which is adding up to 180. Yes, they do. So, You could work and you could create really any triangle you want. I made an obtuse triangle. You could make an acute triangle. Somebody else could make a right triangle. It wouldn't matter. Make any triangle you wanted to. And we looked at the 3 different angles. We cut them off. We arranged them. And what we indicated is that the sum of the measures of the angles of a triangle is always 180 degrees. So the 3 angles that you have will always individually add up to 180 degrees. When you add them up all together, it makes 180. So that's true about any triangle you make. Any triangle. So let's come on down here to this triangle. What do we see? Guess I already gave it away. It is a triangle. We see that it's a triangle. Now, how can we possibly figure out what the value of x is? To do that, you need to have a relationship. You need to know what's the relationship between these angles. We know that all 3 angles are going to add up to 180 degrees. Oh, this one was 40. My next example is 44. Thanks for pointing that out. So then we collect our like terms. Notice we have 4x's and 3x's. Some mistakes that people make, they subtract the 3x and put it underneath the 4x and only get 1x. But that's not how you collect like terms. If you're on the same side of the equal sign, you're going to say positive 4 and positive 3 is positive 7. A negative 5 and a positive 5 cross each other out. Then you have your 40. You subtract your 40 to get 140. We divide by 7 to get 20 degrees. Or 20, it's not degrees, it's just a 20. It's just an x value, it's not an angle, it's x. Find the measure of each angle. Well, we figured out 20 for the x value. So now we're going to say 4 times 20 minus 5. That's 80 minus 5. That's 75. The other angle is going to be 3 times 20 plus 5. 3 times 20 is 60 plus 5. That's 65. So we have a 65 degree angle, a 75 degree angle, and the given 40 degree angle. Think about what we did there. We took the sum of all 3 angles. We added them together. That's called the sum. And no matter what style of triangle you have, it always adds up to 180. The last one we're going to look at is this one. What's different about this triangle, or this example which creates a triangle? Read through this, think about it. Alright, so I would encourage you as often as you can to draw your own triangle. They don't give us letters for this triangle, so you don't have to label it by letters. You know that one of the angles in the triangle is 44. Of the 2 remaining angles, now listen to this. This gets confusing for people. Of the 2 remaining angles, one of the angles is 3 times the measure of the other. So 3 times the measure of the other. What are we going to do? How do we label these out? Any thoughts on what are we going to put in our picture? One of the angles is 44. The other one is 3 times the measure of the other. If you have an angle that's 3 times the measure of the other, x is the other, this one is 3 times the measure of the other. There it is, 3x. So we have x plus 3x plus 44, and it's a triangle. It adds up to 180. Your like terms gives you 4x. You subtract the 44 and get 136. 4 goes into 13 3 times with 1 left over. So the x is going to be 34. The missing angle is going to be 34 degrees. The other angle is 3 times 34. So that's 90 and 12, which is 102 degrees. So apparently 102 plus 34 plus the other angle of 44 is going to make 180 degrees.